The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content.
Our last speaker is Bob Armbruster.
Thank you, Kimberly. Well, I'm going to tell you a bit about Earley's secrets. He was a businessman, but as well as an artist, and he kept a number of things close in the studio as trade secrets. He obtained patents, as Jenna mentioned some of those, and he eventually licensed others to do the work under his license. And he wrote fabulous articles that the ACI has agreed to let them be republished in the special symposium publication coming out sometime next year. So there will be articles of all these presentations with even more detail and all of Earley's articles. But even though he very correctly, exactly, technically described his process, he always didn't tell you something that you needed in order to make it work. So he had no competitors that could compete with the quality or the appearance. However, having to restore his work, we have figured out a good bit of what's between the lines. The Baha'i temple began back in 1906 when the small Baha'i congregation in Chicago identified a site on Lake Michigan and began to acquire land. And for many years, and by the way, this was women who initiated this and led the way in many of the temple's construction efforts. Well, they had an international competition. Now, there were less than 1,500 Baha'is in all of the United States 20 years later when construction began, but that meant nothing to this very bold group. They said, we'll have an international design competition. And this model, 10 foot tall, was one of the submittals. Louis Bourgeois, who was a French-Canadian-born architect trained in Paris, took 2 years to build this because he didn't think his drawings conveyed his idea. What he designed was a single high domed space with light streaming in during the day through tens of thousands of filigreed openings and then out again at night from lights within. Now, it was wildly proclaimed as a great new bit of architecture after it was selected, but no one knew how to build it. This was 1912. Bourgeois, right after he got the contract, began traveling around the country, taking photographs of his model and taking his drawings. And Bourgeois is on your right, John Earley's on the left. Now, a little bit, it reminded me when I saw Laredo Taft's photographs in his schmuck at dinner, his artist schmuck. Louis Bourgeois was much the same artist, architect, and so his photographs have him in the artist's smock and so on. But John Earley would have greeted him at the door of his studio in his artist's smock because John Earley was a practicing architectural sculptor. Well, 1920, Bourgeois storms in and forget about niceties. He says, "Can you build this with your new material?" He had been told Earley had this new material. Shows him that picture, which just took Earley back. And, Earley couldn't say yes at the moment, but he started to give it thought. The two of them had a lifelong friendship and correspondence. The Baha'is also couldn't get anyone to tell them how it would be built. They appointed a committee with leading architects and engineers, and the committee began searching for materials. They quickly identified terracotta wouldn't do it. Carved stone couldn't do it. This dome was less than the thickness of the shell on an egg in proportion, with all of these openings. So it was just not structurally possible to do it with stone. Even cast aluminum, like we have here in the Capitol Dome, they felt that wouldn't have the luminosity they wanted in the finish. Well, the committee asked Bourgeois to do some drawings so they could get samples. Bourgeois said a drawing won't convey it. He had a sculptor do models for the detail in one ornament, or one window. They had samples made in terracotta, samples made in cast stone, algonite stone it was, and that was a crushed granite fines. And this was cast into molds and then further cut and ground and refined like you would work stone. And they had samples from John Early's studio. The small samples were considered such a success that a month later they told Bourgeois, we want a full-size piece like we'll need on the dome. Let's see what that will look like. Well, only one of the firms could provide a full-size piece. Guess who? John Early. The terracotta piece was less than half the size. The cast stone piece was not nearly long enough. The 9-foot pieces required couldn't be done by anyone else other than Early with his reinforced concrete. Meanwhile, the Baha'is began with the construction of the foundations and the basement level. And these were the days back in 1920 when they had to bring out a little steam donkey engine to run the dewatering pumps. And this hoist, they manually dug 9-foot diameter, 127-foot deep caissons down to bedrock for the foundations. So these guys were there's Bourgeois in his suit with his rolled up drawings. Ever the architect. Now, it was another 10 years before they could begin the work on the building because the Baha'is had to raise the money. Meanwhile, Bourgeois began to draw in his studio for the ornamentation. He did 63 full-size drawings of the exterior ornamentation on the temple. The largest is 120 feet long, 6 feet wide, going up one of the ribs. And these were beautifully drafted. 1930, the Baha'is had enough money that they could then build the superstructure. The leading structural engineer on the materials committee and who designed the basement and foundations, Major Henry Burt, was the lead structural engineer for Halliburton Roche in Chicago. He had done the Chicago Tribune Tower, the Palmer House, Chicago, the Soldiers Stadium. At any rate, in 1922, they were sitting in the basement, and he said, it's a good thing the Baha'is don't have enough money to continue because it's going to take more knowledge. It's going to take the growth of our industry, knowledge about materials, knowledge about construction, in order to be able to build this. So in 1928, he passed away. In 1930, Louis Bourgeois would pass away. The structural engineer who took over for Major Burt convinced the Baha'is, rather than building one story at a time and putting a temporary roof on, as was often done with churches, let's build a complete watertight superstructure, windows, heating, electrical. That was a complete building, no ornament. And he said, then we will ornament it. The Baha'is said, can we do this? Who's done it? He says, well, no one has done this yet, but much as they take Madam board member and create her dress on a form, we can create the dress for this temple on this superstructure. So they built the superstructure. You can see it here. And then they had to figure out, how do we get Early's drawings into 3 dimensions? Well, it really was Bourgeois drawings. John J. Early's genius as an architectural sculptor that made it possible. He had to translate everything into 3 dimensions. He had to decide how much perforation there should be in the ornament, how deep should the relief be, so that he says, as he put it, if the openings were too large, they overwhelmed the tracery. If they were too small, it became too dark. How do they handle color? All of those questions, it was John Early and his artistic genius that solved that. But it was really a team effort that got the temple built and this architectural material on. John Early's on your left. Alan McDaniels, the structural engineer, is in the middle. And he was a consultant to the Baha'is and the project manager, construction manager. He actually received the first Wasson Medal in the ACI. His paper in 1916 was The Effects of Temperature on the Curing of Concrete. So he was that much of a pioneer at the time. Basil Taylor on the right was John Earley's partner in every sense of the word, although Earley only sold in the studio when he was near death for $1. Basil Taylor was the wizard of production, and you'll see what he did. Now, this project was much larger than what Earley and Taylor could do in their Foggy Bottom studio, the original studio that Earley's father had 4 blocks from the White House. If you look in the center, you will see a red dot for the Foggy Bottom studio. By the way, on the upper left is hotel. That's where we're sitting now. Meridian Hill Park is less than a mile away. The Foggy Bottom studio, continuing around to the White House, it was about 4 blocks from the White House. John Earley, I understand, was quite the fencer and used to fence with Teddy Roosevelt, one of the sports events. Now, their new Rosalind studio is down in blue. We were able to locate it on the old maps, actually, close to the Iwo Jima Memorial. It was larger in size. They kept the Foggy Bottom studio going for 4 years for a lot of the fine architectural detailed work. But the first thing that Taylor built was the modeling and mold-making studio building. And they began, and you can see the sculptor laying out, you recognize that pattern, it's from the Baha'i temple, the clay on there. To control the geometry, Taylor worked from the back of the dome and used that hemispherical shape to control every bit of the geometry. There were, by the way, less than 20 dimensions on the architectural drawings that defined this whole dome. Not because they couldn't put more, but that's all that was needed. This was an elegant design geometrically. Difficult to build. So here you can see some saucers of plaster on the floor. Those represent the back of the precast concrete panels, and they are casting curved base plates for the models. And then in the studio, they would either put the model up vertical or leave it on the floor, and they applied 4 inches of clay, sculpting all the relief and the detailed ornamentation. Here you can see a part for one of the rib pieces. It would eventually be precast and 3-sided. First, they started with that curved base. They knew that curve was going to fit on the building. Then they built a wooden interior template and applied all of the clay modeling. What you see in the bottom is a plaster intermediate. It took multiple generations of a plaster mold from the clay model, and then they refined the mold. Then they made a plaster mold from the model from the plaster mold. They refined the mold, cleaned up the joints, and finally they would make a mold for the concrete. But that plaster model had to be exactly the size in 3 dimensions of the precast they wanted in the end. Here you can see a number of the rib pieces in their modeling studio. Now here's the team. John Earley is not in these photographs. He's only in a few photographs, and I believe it's because he's the one behind the camera. He would have been the one that would have been up on all those things. And so all these photographs, I think, were taken by John Earley. Earley and Taylor were members of the Plasterers Union, and their studio remained a union shop, and this let them hire additional skilled craftsmen and artisans as they needed it, whether it would be here in Washington, in Chicago for the Fountain of Time, in Nashville for the Parthenon, so they really could take standard methods in the craft of plaster and art sculpting, architectural sculpting, and apply them. Here they're refining one of the panels for the dome, and you can see they've got all the openings, the perforations in there in the plaster. Here's on the upper left, a model in plaster, and in the lower right, the actual precast piece installed on the temple. Now you'll notice in the model there are smooth kind of edges along the perimeter that you don't see completely in the finished installation. That's because Earley would take precast elements. They were coming from a background of cast stone, smaller masonry size elements that were set into the architectural facade and set with other stone, mortar, bricks, what have you, and placing it in this concrete structure, and they kind of glued it all together by casting additional exposed aggregate concrete along between the pieces. While the model making was underway, Basil Taylor, and that's him on the right in that great cowboy type hat, by the way, he's out there surveying, pouring concrete slabs for the base of a full-size template of mock-up of 1/9 of the Baha'i dome, so that they could match every piece they had to make up on that. He exactly modeled the purlins, all the trusses. He knew where every piece of the structure was, and that was in wood. On this, they began to install the plaster models for the what would be precast pieces. They hoisted them up, anchored them onto the purlins, and you can see on the right how thin these pieces were. Then, as they built up more and more pieces, they would go up, and you can see where the red arrow is, one of the artists up there refining the joint. The joint between pieces is 3/8 of an inch wide. It's an open joint. And he's refining the movement of the ornamentation across from one panel up to the next to make sure that the planes, the irises, the relief, all is consistent. Now, I love this sign. This was on their modeling studio facing the street. The Baha'i Temple Dome, the most elaborate concrete structure in the world. There really was no precedent for what they were doing. And I say our because Sid Freeman and I have both looked for what was the first architectural precast concrete buildings that were done. I have found 2 or 3, 2 in France, 1 in England. This is the first one here. Those are the only 3 earlier dated. But there was no precedent for what they were doing, and it's certainly, even today, is up there with the most elaborate. Here they're modeling the rib that will be at the base. This goes from the roof up into the dome, the base of the ribs. If you look in the background, though, they're doing that on the outside of the modeling studio on the left. In the background, you'll see they're building something. This is the casting yard. So they were well along with their mock-ups. You can see in the background that tall dome structure and the plaster mock-ups on them when they were still constructing their casting yard. And to go around here, from the upper left, the model and mold studios there in the back, and you can see that plaster model of the rib. The mock-up was on the far side. They had an overhead crane. The runway was 350 feet long for the process. Jumping to the left again, they put the crusher, screener, and mixer in a shed on the outside. And I'll tell you more about that. The casting shed was under roof, but it was open air. Then they hoisted and rolled things out to the cleaning and curing yard. Taylor built a curing chamber in the middle of this 350-foot long crane runway with a canvas roof that he could roll back and roll up. And of course, at the far end of the runway was the railroad yard, the railroad siding. This is the mold that they would finally construct. This is for one of the panels on the dome. They had, I think it was 27 unique pieces, but because they repeated up to 9 times, that was the economy that they were able to achieve. If you look carefully, there's a shiny edge in the foreground edge, like a shiny lip. That's the edge of the lead foil, and it was almost a foil, such a thin sheet that they could mold it to every little sharp iris of the mold. In the Parthenon in Nashville, which is the building itself is the biggest piece in the museum, but they do have some molds left, including one from the column, a piece of a column mold, and it still has the lead foil on the inside. And I don't know if they use size or shellac to initially bond it, but they would shellac them when it was done. Every one of those knobs in the middle is a removable plug that keys into the base background mold, but freely comes out when the concrete piece is removed. because otherwise they could never get the concrete piece out. The sides all unbolt and come off. There are more than 50 pieces in this one mold, and yet everything fits together precisely. Here they're making the reinforcing steel. This was less than 1/4 of an inch diameter steel rods, and they spot welded them all together following the three-dimensional curves of the pieces, maintaining a 1-inch cover or distance back from the surface. They did it beautifully. On that whole building, we found less than a dozen spots where the reinforcing was a little close. They then hot dip galvanized the reinforcing, but the critical element was the pebble, the aggregate in Earley's Mosaic concrete. And here you can see some of that. Well, the aggregate was slightly less than 1/4 of an inch in size, and no one, after the first job or two, when Earley said, I need it this size, no larger, no smaller, well, no one would supply them with any screened aggregate at all. So Earley had to build his own crushing and screening operation. By the way, the mixed proportions for this, the sizing rather, is this was their pebble aggregate was minus 1/4 of an inch and plus a number 8 screen in our current Tyler series. The sand, and Jenna mentioned that they had to pull more water out for the Baha'i job. He did that by changing the bottom or the smaller screen for his sand, and he changed it by 14 1/1000ths of an inch in order to eliminate the surface hold by capillary action of the water to that sand. And the next piece, he only did one bad piece. It cracked. He went back, studied, as Jenna said, changed that bottom screen. The next piece was a success, and that was it. Well, that was he went from a minus 60 screen to a minus 40 screen to a plus 60 screen. When we first began restoring the Baha'i Temple project, we didn't realize how precise that sand had to be, and we did a lot of samples before we finally got the right appearance. He had trainloads of rock delivered directly to his yard. He selected it by hand for color, for quality, sorted it, took it by wheelbarrow to his crushing equipment. He had a 10-inch jaw crusher and a 12-inch roll crusher, a series of screens and recirculating belts in order to take the middle size and crush it again so he could reuse it. And he achieved a 60% yield, which is very high for aggregate in the processing. This is in the casting shed. On the left, you can see the molds laid out, getting ready for casting. On the center is the crane runway. On the right, you can just make out there are bins of sand and pebbles. And what you don't see is the mixer. I say the mixer because this is the mixer that was used for the whole Baha'i job. It's a 1-bag mixer, and Earley's proportions were 1 bag of cement, 110 pounds of his sand, 300 pounds of his pebbles, and from 4 to 6 gallons of water. Why 4 to 6 gallons? It depended on the shape of the piece. It depended on the access they had to get water back out, whether they could use a porous core, all of that. As he put it, at the time of curing or set, we want about 4.5 gallons or less of water in that mix, which would be about a 0.38, 0.4 water cement ratio. This is what the mix looked like in that wheelbarrow. Very coarse, very harsh. When we first tried this, we said, well, you got to be joking. How are you going to put this in a mold? Before we got this photograph and saw that is what it looked like. And up above, you can see a margin trowel on the edge of the mold. That's what they placed this with, margin trowels and sticks. They tamped that in by hand, every corner, every crevice, working the pebble down to the surface. Once they got the face mixes on, they put the reinforcing steel fixture in and placed the backup mix. The next day, they had 40 minutes to expose that panel before it was too hard once they got it out of the mold. And they had to use wire brushes, like an artist's brush, smaller than a toothbrush. So they had everybody in the shop, the crushing guy, the delivery guy, everybody over to do the exposure. But they got crisp, sharp results. They brought it down in the yard for curing, staging. They gave it 2 acid washings, not to expose the aggregate, but just to clean the cement film off. It was the dilute acid mixture of water. They had the challenge of putting that puzzle of a mold back together the next day after cleaning all those 50 pieces so that they could make another piece. They brought it down to the end of the yard. They had a derrick to the railroad siding, loaded it, shipped it up to Chicago. They knew how revolutionary this was for the industry at that time. They hired a local trucker to bring it over to the temple. That's Basil Taylor in the light-colored suit on the right. Here they are with some of their first deliveries. John Earley taking a photograph of everybody there. Most of these workers were plasterers hired from the local Chicago Union Hall. The first work, though, was cast in place. The base of the ribs was cast in place on the building. And over on the right, you can see that rib in place up on that high roof. And then they're hoisting up the precast panels. Now, Basil Taylor on the left feels perfectly in charge. The guy behind him has his doubts, I would say. And here you could see that they actually rode the pieces on the derrick getting up and down off of the building, something that we would never be able to do or want to do today. Now, this photograph, you can see a little reveal down towards the lower part of the edge. They took T's, and that's what the panel is resting on, a T-section, inverted it so that the standing leg of the T really shaped outwards from the center of the building. And that was the place that the panels rested on. They built a reveal in the panels to keep a 3/16 inch open air around the panel on all sides of the joints. But they finished the dome, really one of the first architectural precast concrete projects. They went on. It took 17 more years of steady work to finish the job. Using the same techniques, here they cast the soffit in place on the building. You can see the model on the upper left. They're molds there, and they sequentially moved them around that big cornice. The lower photo is after we restored it. Most of the restoration, by the way, was not correcting material problems, but correcting flashing and roofing problems. Like most monumental buildings, there was no precedent. And with that scalloped edge, they buried the flashing and water got in. What's often surprising is they cast many of the exquisitely ornamented pieces in place on the building, shipping their quartz, pebbles, and sand and molds. Here you can see an arch over the entranceway. It's made up of 2 of these C-shaped arch pieces with a center flat ornamented arch. And in the lower left, they're casting that center piece. And they have to do it in stages with shuttering and back forming, rolling the mold into the next position to cast the subsequent piece. By the way, there were dozens of plugs in that mold that you can't even begin to see in there. They did hundreds of filigreed pieces, set them in. Those pieces are like 2 inches thick with 1.5 inch grout behind it. You can see how fabulous the sculpting is. That, by the way, that's 80-year-old concrete in the lower right. Crisp as day one. This, I wanted to show you how fine and delicate it is. That is, on the right, that is a precast piece. It's out in the gardens, but it's from one of the window panels, the filigrees. That is only 2 inches wide at the narrowest area and 2.5 inches thick, but it has 1.5 inches of depth in the shallow relief to create all these shadow lines and ornamentation. And the building is full of this. Even up on the very top of the dome where you can't see it unless you're up there doing maintenance, they have berries and acanthus leaves and everything perfectly detailed. The interior, the Baha'is didn't think they could afford Earley Studio, who did the first project, by the way, on a time and material basis. They gave the Baha'is a very detailed budget for 5 phases of work, and they followed that, and their budget was actually right on target, even though it took 15 years. The interior, the Baha'is got bids from ornamental plaster studios. Earley said, well, you've got to give us a chance. Now, John Earley had passed away, but Basil Taylor was in charge. Basil Taylor prepared a budget, and it was lower than the plasterer's bid for plain white plaster to do multicolored Mosaic concrete precast. They used the mock-up in their studio because it was a smaller scale. Same process. They hoisted scaffolding, suspended it actually to create a false floor as they put the dome pieces on. But the result is definitely, it's an architectural breakthrough, an engineering breakthrough, and certainly for our concrete industry a breakthrough. So please visit the Baha'i Temple when you're in Chicago. You can reach it through the public transportation and enjoy it when you're there. Thank you.